Some fighter jets are built so unstable that without computers they'd crash in seconds. This video will unpack why designers deliberately make them unstable, and how flight computers keep them flying. We'll cover the pitching moment curve, static versus dynamic stability, and the control laws that act like an invisible pilot. Static versus dynamic stability, neutral point and CG, short period and fungoid modes. We'll open the black box of FBW on F-16, Su-57 and Tejas, how they move surfaces hundreds of times a second. Then we compare WADI-2 stable gun platforms to modern unstable agile fighters. Start with one curve. Pitching moment coefficient about the CG-CM of alpha. If DCM-DA is negative, a nose-up disturbance creates a restoring nose-down moment, statically stable. If DCM-DA is positive, disturbances grow, statically unstable or relaxed static stability. The neutral point X_NP is where DCM-DA equals 0. Static margin SM equals X_NP X_CG/C bar. Positive SM needs tail downforce to trim, adding trim drag. Moving CG aft reduces tail load and trim drag. Dynamic stability is time behavior. Short period is fast changes in alpha, and pitch rate, damped by CM_Q and control laws. Fungoid is slow energy trade between altitude and speed. FBW and auto throttle usually mask it. Dutch roll mixes yaw and roll, handled by yaw dampers and blended roll yaw control. WADI-2 fighters had positive static margins. They were stable gun platforms, easier for pilots with iron sights and no computers. Modern combat needs instant nose pointing for off-bore sight missiles and helmet cueing. Agility beats steady platforms. So designers move CG aft toward or past the neutral point to reduce trim drag and boost transient response. An unstable jet is like a pencil on your fingertip. IMUs, air data, and multiple sensors feed triplex or quadruplex computers that run control laws. Actuators, elevons, rudders, and on some types thrust vectoring let the computer allocate moments efficiently. Inner loops, damp rates. Outer loops map stick to G or attitude. Limiters protect against stalls, over G, and pilot-induced oscillation. F-16 Tejas and Su-57 use RSS plus FBW to trade steady stability for instant maneuvering authority. Deliberately unbalanced aircraft, tamed by computers, faster nose, less drag, and a new era of air combat.